Hey, what's going on, guys? Part 2 of this video. No introduction because I assume you're hopefully watching part 1 or else none of this is going to make any sense. Alright, so other directory that's really common inside any project is a third-party directory, and this could be named or organized in various ways, but the whole point of this directory is to hold third-party code, aka any code that's not your own that's helping you. So if all the code you write is going to be in source, right? But obviously you're not coding everything from scratch. There's no point in reinventing the wheel. We all know that. So always, there's third-party libraries to help you. So there could be some nice helper library that you're pulling into the project to help you, which comes with a set of libraries and includes. So what exactly is includes? And this will be an introduction to what this means. So the library is pretty self-explanatory. It's going to be like some helper library, or helper libraries will come inside here, and you're going to also have a header file for this library, which would look like this. And let's just talk a little bit about why you can't really just have this. You really need a header file. And usually when you pull in third-party libraries, they'll have at least some libraries and a few, if not many, header files. All right, let's just go back to terminal real quick. So I'm inside the library file. If you guys can see this, check out the left now. These are some library files. Obviously, I'm not in a project or anything. If I was in a real project, these files would probably exist under a third party. So let's just take this one, libx tables. I have no idea what this does, but you know, something with tables, and it's a shared library. And what would happen if somebody just gave you this library by itself? Well, actually it would be nonsense, because this library, it's just a straight up binary file. This is like nonsense, right? What if somebody just gave you this file and it's like, here you go, that's all you really get? So that's exactly why we have things like header files. Header file will match a library or a set of sorry, I'm speaking too fast. A set of header files will match a library to give you a nice interface into the library. And let me just find a header file to show everyone. Should be one in here. Nope. In here. Nope. Sorry. Where are they? Okay, so finally found just a simple header file. And remember, in this ecosystem, a header file is the interface into a library, and you need it, or else you can't just look at the library binary, because we just looked at it, it's nonsense, and it's not supposed to be human readable. So if we just look at this one is going to be a human readable header file authored in 2000 by Dimitri, which has the interface to whatever this library is. And this is going to be usually like a well-documented human readable file that, you know, is going to mean something for a different set of libraries. So that is the purpose of a header file. I hope that's clear. It's just that every time we build libraries and you want another developer to use your library, it has to come with an interface into that library, or else it will really make no sense. So this actually goes into what this directory means. Like we said before, what are we building in this project? What exactly are we building? Well, we know we're already building the ls executable, but we're also building a library. Like all this source code of the core ls functionality, we're building a library for that. And we can't just ship these nonsense binary library files. We actually have to ship a header file. So in an include directory is going to be ls core. Let's just call it lscore.h, and this could be we write a header file for our interface to the ls core function. Just like we include header files here when we pull in third-party libraries, maybe somebody's going to want to pull in our core library. Maybe somebody wants to use the ls core library, in which case we cannot pass them just these files. We also have to pass them the public header file. So I think I repeated myself like 50 times in those a few minutes, but I hope it's clear why we need those files. All right, so let's just keep moving on. All right, guys, almost done. This video is getting pretty crazy, but the last directory that we want to just go over is artifacts. What are artifacts? This is a pretty cool name, but what these are like the final files. And after everything is all said and done, usually what goes into artifacts are final files, or pretty much the culmination of everything you want to build. So let's just go over what is, I think you guys already know what's going to go inside this file. Remember, we're building an executable and we're building the core ls library. So artifacts are going to usually look something like this. The final libraries, the final binaries, the public files, and probably some docs. So let's say after all this is said and done, after all the source code is built, we will get some artifacts at the end of it. And remember, what libraries have we produced? Well, we're actually producing the core ls libraries. Maybe we'll have a shared version of this produced, and we'll also have a static version. Sorry for this page break. Let me just... So, right, final library files. 2 of these bad boys, final libraries. There's going to be a final executable file, which is the ls command as we know it. For include, we're also going to include our ls library header file to use the libraries. And obviously, if any developer wants to use these libraries that we're providing them, they need the header files, or else this will be gobbledygook. All right. And finally, very common in artifacts is documentation. So we've documented our code very well and generated, countless documents of how to use this libraries. And usually inside artifacts, you'll also have somewhere to install documents. And those are probably the 4 core things, but there's many more kind of final files that appear here. So this is pretty much, artifacts is the culmination of any build process. All the final files are going to go here. Now, the last question we have to ask ourselves is, how do we get artifacts into the system? And this is a pretty crazy question. I'll try to talk through it a little bit here, but actually I take it back. So I think these 2 videos we already talked about a lot. It's a lot to digest. So let's just talk about this as a question without going into it. Pretty much what we talked about initially is a basic project structure to produce executables or binaries. Like, remember, we took ls as an example of a cool executable that everyone uses and how that might potentially be built in a templated project. I just made a kind of simple common directory structure here for this project, and we produced an executable and a library. So at the end we got all these cool artifacts here, right? But how do the artifacts actually get into people's system? Like, this is just a developer building source code, right? Like, how exactly does ls get installed into like every single Linux computer around the world? That's like how it's distributed and installed. And this gets into some really cool stuff like packaging and package managers and distribution, building projects for cross-platform stuff. And can't go into the details of what this stuff means here, but if there's any Linux users out there, I'm sure you use different package managers for different distributions, and pretty much these things are the core things that get these artifacts distributed to everyone. And building it is one part of the puzzle, and the second part of the puzzle is deploying it. or getting it out there. And that might be the discussion of, that might be the discussion of another video, but not today because I'm kind of tired. But we definitely went through a lot. Please, I'll just wrap up the video here. Things might have gone through really quickly. I know I rushed through maybe a lot of things. There's a lot of concepts that were presented. I would just suggest everyone to maybe just rewatch both parts of the video very slowly. And if there's any word or any little step that doesn't make sense, just pause it and Google it and try to reconcile your thoughts. Don't try to watch the video straight through if there's missing pieces in your head. So I really tried to just give a basic overview of building something as simple as LS. So I hope it was helpful. Please leave me a comment in either video if you have any questions. How do we get artifacts into the system and package managers, I'll do this in a separate screencast after I think about it a little more, because there's actually a lot to talk about in this realm. All right, guys, definitely hope you guys enjoy the video. I'll catch you guys next time with maybe a screencast or another video or what have you. Please give me some suggestions and take care, all right? Have a good week.